A helicopter starting from rest accelerates straight up from the roof of a hospital. The lifting force does work in raising the helicopter. An 810-kilogram helicopter rises from rest to a speed of 7.0 meters per second in a time of 3.5 seconds. During this time, it climbs to a height of 8.2 meters. What is the average power generated by the lifting force? So for this problem, we needed to find the average power, which we know that power is equal to the work divided by the time. And our work is going to be equal to our entire energy. And we know that energy is equal to the potential energy plus the kinetic energy. And potential energy is the same as mgh, the mass times the gravity times the height. And the kinetic energy is the same as 1/2 the mass times the velocity squared. So looking back at the problem, we can get the values to plug into the formula. So energy is equal to the mass, which is 810, times gravity, which is 9.81, times 8.2, which is the height, plus 1/2 the mass, which is the same, 810, times our velocity, which is 7 squared. And then we solve to get the answer that energy is equal to 85,003.02 joules. Now, going back to the original formula that power equals work over time, we know that our work is our energy. So P equals energy divided by the time. Now we can plug in the values. We know that power is equal to 85,003.02, which is the energy, divided by the time, which we are given in the problem, which is 3.5 seconds. So when we solve this, we get our final answer that power is equal to 24,287 watts. And that would be the final answer. You are working out on a rowing machine. Each time you pull the rowing bar towards you, it moves a distance of 1.2 meters in a time of 1.5 seconds. The readout on the display indicates that the average power you are producing is 82 watts. What is the magnitude of the force that you exert on the handle? So, since we are given the power, we can use the formula that the average power is equal to the work divided by the time. So we are given in the problem that the power is equal to 82 watts, and we are given that the time is equal to 1.5 seconds. So we can plug that into the formula, which is 82 equals the work, which we do not know, divided by 1.5. And now we know that work is equal to the force times the displacement. So we know that our displacement, as given in the problem, is 1.2. So when we put in the formula, 82, which is the power, is equal to the work, which is the force, times the displacement being 1.2, divided by 1.5, which is the time. And now we can solve for our force, and that would give us the final answer that force is equal to 102.5 joules. A person is making homemade ice cream. She exerts a force of magnitude 22 newtons on the free end of the crank handle on the ice cream maker, and this end moves on a circular path of radius 0.28 meters. The force is always applied parallel to the motion of the handle. If the handle is turned once every 1.3 seconds, what is the average power being expended? So since they're asking for the average power, we can use the formula power equals work over time. Work is equal to the force times the displacement. And we know from the problem that our force is equal to 22 newtons. Now for the displacement, we do 2 pi r, which is 2 times 3.14 times 0.28. And once we do that, we get that our displacement is 1.76. So once we multiply that times the force, which is 22 newtons, we get that our work is 38.72. Now, we know that the time, it was given in the problem, the time is equal to 1.3 seconds. So now we can find the average power by doing power equals 38.72 divided by 1.3. And then we will get the final answer, which is that power is equal to 28.67 watts.